In this tutorial, I'm going to discuss what radioactivity is, and I'll describe the 3 radioactive emissions. Let's get started. I'm going to write out the word radioactivity on the top of my Cornell notes. Let's talk about what this is. So radioactivity is when occurs when many large atoms have unstable nuclei. The word nuclei is plural for nucleus. So one atom could have an unstable nucleus. Many atoms could have unstable nuclei. All right, so when an atom is unstable, what atoms will do is try to stabilize. And to do that, atoms are going to emit. Emit means to give off. They're going to emit particles in the effort to stabilize the nucleus. Now, what particles are those? Alpha particles, beta particles, and gamma rays. Let's talk about those next. So you're going to use this graphic organizer in your notes. Please glue it in. Let's go ahead and start talking about alpha particles, beta particles, and gamma rays. These are radioactive emissions that come from an unstable nucleus. Let's get started with alpha particles. The symbol for alpha particles is the Greek letter alpha, and that's what it looks like right there. It's kind of like an A with a couple extra lines on it. The way that we're going to be talking about alpha particles, though, is using this symbol. The symbol for alpha particles that we use it's really actually a helium nucleus. It's a helium atom without the electrons on it. And so helium has 2 protons, 2 neutrons, and it's emitted from a radioactive unstable nucleus. The mass of an alpha particle is 4 atomic mass units. So it's pretty big. In fact, it's the biggest of the 3 that we'll talk about. This speed is about 1/10 the speed of light. So relative to the speed of light, it's pretty slow. The penetrating power of alpha particles is weak because alpha particles can be stopped by a piece of paper. All right, I'm going to switch up colors. I recommend you do the same thing. Maybe you use a different color pen or maybe a colored pencil marker. Let's go ahead and talk about beta particles now. Beta particles have a symbol of beta, the Greek letter beta. The way that we're going to be using them in the classroom, though, is this symbol. A beta particle is a high-energy electron that's emitted from the nucleus. And so our symbol for it is E, well, just like the electrons that we're used to. Because it's an electron, the mass is very small. In fact, it's an electron, so the mass is 0.0005 atomic mass units, roughly. This is 1/2000th the size of a proton. Okay, they're a little faster. In fact, these are, the size of an electron, just so you have that in your notes. Okay, the speed is faster than an alpha particle. It's 9/10 the speed of light as it's shot out of a radioactive unstable nucleus. The penetrating power is a little bit stronger than the alpha particles. If beta particles were being emitted from something in the room, I'd probably want to step away from it because it can do some damage to your body. But beta particles can be stopped by aluminum foil or even just a piece of glass. All right, and the scariest of the 3, gamma rays. Gamma rays are denoted by the symbol gamma, Greek letter gamma. I sometimes use this one here too. The zeros represent 0 mass. Okay, in fact, the mass is 0 mass. Why? Well, because it's light. Light doesn't have mass to it. The speed is the speed of light. You know why? Because it's light. Kind of makes sense, right? The penetrating power is the strongest of the three. It can do a lot of damage to your body. So if there's something emitting gamma rays in the room, you'd probably be best to walk the heck away from anything that's doing it. Or get behind a big slab of concrete or a huge piece of lead. Will probably be able to stop most of the gamma rays from entering your cells and breaking up some of those bonds that exist between your DNA. So that's that. Those are the three major emissions from radioactive material: alpha particles, beta particles, and gamma particles.